What's poppin', dogs? Mr. Allen here, solving some polynomial inequalities in this video. I've got a cubic function and a quartic function to solve, and two different scenarios of inequalities for each. So I'm going to start over here on the right, so the writing's not all on my face over here when I'm doing this one. So I have a quartic function, trinomial, it's got three terms. We can factor this in the same way that we'd factor quadratics with like AM method, add, multiply, that whole strategy there. But instead, we'll be using x squared and x squared in our two binomials. We often refer to this as factor using quadratic form. So what multiplies to 16 while adding to negative 17? Well, that'd be negative 16 and negative 1. So I'll have x squared minus 16 and x squared minus 1. Cool? But we're not totally factored yet, right? We're going to solve this as if we're looking for our x-intercepts to then graph this thing. So I've got these graphs here so we can graph them and see how these inequalities work. And then you can also do it with a sign chart, but for this one, I'm just going to focus on the graphing way. All right, so I'm going to continue factoring here. Difference of two squares with both of these would be x minus 4 and x plus 4. And then I have x minus 1 and x plus 1. So if I wanted to figure out where my x-intercepts are, where this equals 0, because that'd be a key point in figuring out when it's greater than 0 or when it's less than 0, I want to find out when it's 0. Let's set this thing equal to 0, right? And I can get all of my x-intercepts here. And whether we write them as x equals 4, or we can do 4, 0, I'll go ahead and write, I guess, our intercepts since we're going to be graphing them. We got 4, 0, negative 4, 0. So this is actually a great review for graphing polynomials. That was a slight voice crack, but we'll leave it in here, right? I don't want to start this video over just because I had a voice crack. Now I can plot all these x-intercepts. So we have negative 1, 2, 3, 4, negative 1, positive 1, and positive 4. Now, in my classes, I always make them graph a y-intercept as well. If I plugged 0 into my original, I'd get 16. Now, that's not necessary for solving with inequalities here, right? I really don't care, but if it asks for you to graph using x-intercepts and y-intercepts and then solve the inequality, perhaps that's how I'm going to ask the question, then you better put 0, 16 for our y-intercept there. Easy to get it from standard form. Trickier to get it from factored form. You can still do it. Each form has its own benefits, okay? So what kind of shape graph is this? Well, it's a positive quartic, so it is a W shape. I'm going to pass through, up, down, and up. I mean, that's a nice graph right there. I'm going to go ahead and label that bad boy g of x. And now we can get to work on solving this polynomial inequality. So sometimes it's just written as this right here, less than 0 for like this situation, or greater than or equal to 0. But because I wanted to do a couple examples, I just gave us a function and then I wrote the function notation with the inequality. You should be able to handle it in either way. So for this one, I will go ahead and just jot this down. Like we could have covered up that g of x and it would just be looking like this, okay? So that is an option with how these things can be written. So when is that happening? When am I less than 0? Well, that's when I am below the x-axis there, right? That's when I am less than 0. What happens at these points? Well, I'm equal to 0. So do I want to include those points in my answer? No. So I'm going to use interval notation here above the line, and then I'll do set Miller inequalities for below it, just depending on what your teacher uses. I like interval notation for these. So we're going to go from negative 4 to negative 1, union, and then we have 1, to positive 4. That is when this thing is below the x-axis. That's when it's negative. That's when it's less than 0. If you were to do this with inequalities, you would do negative 4 is less than x, which is less than negative 1. And I usually use like a comma there. I don't use this form too often, so hopefully my notation is all good. But there we go. That's the equivalent form of interval notation. All right? So that's the first one down. No big deal. That's dope. We'll go orange for this one. Greater than or equal to 0 this time. So where am I greater than or equal to 0? Well, it's going to be up here, and right there, right? The sections that are above my x-axis. Am I including my x-intercepts this time? Well, when x is negative 4, it equals 0, right? Negative 4, the output is 0. When it's 1, the output is 0. So yes, I would include all of those points here. Well, how do we do that with interval notation? You're going to use brackets instead of parentheses. Now that we're dealing with like the ends of the graph, I also find it helpful to put like a negative infinity here and a positive infinity over here. Oops, that was a little... Yeah. And then you can even write down your values if you'd like. You could be like, okay, well, I know that this is -4, this is -1, this is +1, +4, right? And then you have all your values like listed on here that you're going to be using in these problems. So if that's helpful, go ahead and label your key points here on your x-axis, all right? So when am I above 0 or equal to 0? Well, that's going to be this left section right here. So from -infinity to -4, we're going to include that -4. Now, I had a great question come up in class. They're like, wait, why do you have parentheses on the infinities but brackets on the numbers? Well, can you ever get to -infinity? No, you cannot, right? It just keeps going negative. You never can get there. So we can't include what we can never get to, right? Man, it's like, this deep, bro. It's mathematical poetry right there, you know, right? I can't get to infinity. I can't include what I cannot get to. I can just keep chasing that mathematical dream. Anyways, let's continue. -1 to +1 is also going to be positive, greater than or equal to 0. So union, hopefully I can fit this all, -1, comma +1, tiny. And then we have from 4 on to infinity. So 4, comma, infinity. Let's see if that all fit. Hey, I think we did. Cool. Got a little screen on my watch there. All right. First one solved. Beautiful. Oh, sorry. Inequalities as well, just in case. For this one, you can do like x is less than -4. And then the compound inequality. Oops. Less than or equal to -4. And then -1 to x. Sorry, to 1. And then greater than or equal to 4. Again, I really like the interval notation. I feel like it's more like systematic to me. Inequalities, I start getting weird, especially then when you got to flip this guy around. I don't know. I don't like the inequalities, but if your teacher wants you to use them or whatever program you're typing things into, you know, because we love computers these days, uses them, then go ahead and use them. Hopefully I didn't just hit my watch and stop it. Okay, we're good. All right, on to this one here. Any questions? Any questions? Didn't hear any questions. Okay, no questions here. On to this bad boy right here. We've got, 4 terms. How am I going to factor this? Grouping. Okay, very good. Very good, children. Way to say the grouping is the way we're going to do it. So if I have 4 terms, I'm going to group the first 2, group the second 2, and then I use GCF, which is our simplest type of factoring. Not that factoring is simple. It is tricky. It is my favorite F word. Okay, factoring is my favorite. Function is my second. Fraction is my third. Sometimes I switch those two. Anywho, GCF out of these 2. Well, I'm going to take out an x squared from them, and I'm left with x minus 6. Then over here, I'll take out a -4. Fun fact, anytime this is a negative number, I take out the negative with it. That's going to change the 24 to become x minus 6. And now what I have is these 2 are the same. Well, this is essentially a common factor of this term, this whole big thing here, and this guy here. So that comes out x minus 6. The leftovers, x squared minus 4, are its own thing. Now, because I'm solving, you could set x squared minus 4 equal to 0. Add 4 square root plus or minus, blah, blah, all that good stuff. You can solve that way. I'm just going to continue factoring because we often will even just ask you to factor by grouping. So it's a solid strategy here. But if you wanted to set that equal to 0 and solve right now, more power to you. I'm just going to do it this way because this is my video, bro, and I guess I get to make the call here. All right, so there we go. We got all of our factors. We'll set it equal to 0 now because I want to find out when it's 0 so that I can let people know when it's greater than 0 or when it's less than or equal to 0. And let's get all of our x-intercepts now. We got 6, 0, 2, 0, and -2, 0. Beautiful. And let's plot them. So we got 1, 2, 3, 4, 5, 6, 2, and -2. It's a positive cubic. My y-intercept is 24. So I can either put the point now or I can be like, I'll just plot it when I get there, right? Maybe I'll do that. So I'll just go, wee, woo. And yes, sound effects are necessary. So boom, we've got 0, 24. Got it all labeled. P of x. Boom. Now, we are ready to solve, okay? When is it greater than 0? That'd be my upper section here. Whoop. And this guy right over here, that's when it's greater than 0. Now, would I include my x-intercepts here? No. All right, and if we'd like, we can also put down our key points, like I talked about before, negative infinity, negative 2, 2, 6, and infinity over here, okay? So those are the only values I'll be using in the situation, right? So between negative 2 and 2, so I'm not including, it'll be parentheses, negative 2, comma 2, and from 6 to infinity. 6, comma, infinity. Beautiful. If you're going with inequalities, negative 2, less than x, less than 2, and then we have x is greater than 6. Those are my two that we'd have right there. All right. Sometimes they want you to do like a whole set builder thing, like brackets and x, such that at, and it's all fancy. It's a little too bougie for me. Okay, a little too bougie. I'm more of a street math kind of guy. So I favor, this notation. It gets the point across, right? Settle down, mathematicians. We don't have to be all high and mighty, right? Not everybody wants to do high level math. As long as we can communicate our answer, I think that's good. I choose this form. If you want to do that one, it's up to you, baby. It's America, you know what I'm saying? All right, moving on. Let's go with, deciding if I want to switch colors. Maybe we'll go blue on this one. Let's go blue. All right. So less than or equal to 0. Below my x-axis, boom, and boom. So when's that occurring? From negative infinity to negative 2. It is less than or equal to, so I will be including my x-intercepts here because it equals 0 at that value, right? At that x value at negative 2, we get 0. So if I plugged in negative 2 to this thing right here, I'd get 0. 0 is less than or equal to 0, right? It fits the equal to. So negative infinity, can't include it, to negative 2, got to include it, and then union from 2 to 6. 2, comma 6, boom, done. That is when it's less than or equal to 0. All right, you guys. Hopefully that helps a lot, and you're all ready to rock and roll. Definitely a lot going on here, especially if your teacher asks you to find your x-intercepts, graph it, solve the inequality by graphing. I mean, that's a 5-point problem right there, right? We got some factoring, that's a point. X-intercepts, that's a point. Graphing it, that's a point. And then writing out your intervals, I would say that's another 2 points to really fully solve that thing. So 5, 6 problems. That's a beefy problem right there, all right? So know how to do these. And then if you guys have any questions, pop them in the comments. If you want any other videos made, let me know. Happy to make them. Otherwise, have a great day.